All right, we're going to talk about linear functions and their graphs. So that's essentially talking about x and y coordinates and graphing lines. So the x-intercept, if we're looking at intercepts, the x-intercept, we're going to set y equal to 0 and solve for x. For the y-intercept, we're setting the x equal to 0 and solving for the y. So it's essentially just kind of covering up and ignoring it. So a lot of times, that's going to be the easiest way to graph these equations. So this is an equation in standard form. If I want to find the x-intercept, I'm really plugging a 0 in here. So 3 times 0, it goes away. I have 2y equals 6. So in other words, I can just kind of cover that up. So I end up with 2y equals 6. I'm going to divide by 2, and I get y equals 3. And my x-intercept, I'm going to get x equals 2. Because 3 times 1 gives me 6. Or 6 divided by 3 is 2. So now I'm going to plot these. Y equals 3, x equals 2. There's my 2 points. I connect them with a line, and there's my graph. So I used my intercepts. I really plugged in 0 into these. That gives me 0. 3x equals 6. Divide both by 3. That gives me that 2. So, and when we're talking about lines, when we're talking about the graphs, we're talking about slopes. So slopes are the change in y over the change in x, which is the rise over the run. It's y2 minus y1 over x2 minus x1. Now, you'll also hear this talk about the rate of change. So if we're talking about a specific entity, they'll usually say the rate of change. So for instance, they may say something like the rate of change of height is this. What they're really referring to is that's going to be the slope of your function, but because they're talking about a specific quantity, they use this idea of rate of change. So when you're in story problems or word problems, that's what you're going to see. You're not going to see the slope of this. You're going to see the rate of change. All right, so we're going to find the slope in these sets of coordinates here. So we have y2 minus y sub 1. So it doesn't matter which one of these is x1, y1, or x2, y2. It just matters that you keep the order the same. So if I made this x2, y2, I would go 4 up on top and negative 2 on bottom. So minus negative 1 minus negative 3. So that becomes 4 plus 1, negative 2 plus 3. That gives me 5 over 1, or a slope of 5. So now my next one, I have m equals, and it doesn't matter, so I'm going to go negative 2 minus 4, 2 minus negative 3, so that gives me negative 6 over 5, so I have negative 6/5. So most of you are really familiar with the slope-intercept form of y equals mx plus b. That's the one we really focus on. We really do a lot to solve and work with. And so where m is my slope, b is my y-intercept, okay? So when I graph these, what I'm going to use is I'm going to use my y-intercept. So I'm going to plot that on the y-axis, and then I'm going to use my slope, okay? So the first thing I do is I see that this is negative 2, positive 2. So I'm going to plot that at positive 2. So I'm going to put a dot on my y-axis at this number. If it's negative, I put it in the bottom half. If it's positive, I put it in the top half. So now, remember that your slope is rise over run. So what I always tell my students, and this is just to simplify it, is if this is negative, I'm really looking at down and to the right. So I'm looking at up and down to the right, up and down to the right. So this says positive 2, so I'm going to go up 2, right 3. 1, 2, 3. And yeah, you can go down and left, that works, but a lot of times I just tell them up and down to the right, because they know that negative means down. They know positive means up, and I can take that negative and move it where I want to. And so now I'm going to connect these points there, and there's my graph. So I'm using my intercept, my y-intercept, and then my slope to graph. The last thing we're going to talk about is vertical and horizontal lines. So vertical lines are in the form x equals a number. So x equals 5. That's going to be a vertical line at the x coordinate of 5. Horizontal lines are y equals a number. So y equals 3. That's going to give me a horizontal line at 3. So the next thing we're going to do is we're going to kind of look at graph having vertical and horizontal lines that go through, I erase my H here, through 2, 3. Okay? And so the vertical is x equals 2. So at 2, I have a vertical line right there. And my horizontal line is going to be y equals 3. So I go up to 3 and I go over. Now, a lot of times they get confused in thinking that y is the vertical. Well, because when we're talking about coordinates, y is our up and down piece, and that's true. But remember that what this is saying is my vertical component is always 3. And so my x can change, but it's always going to equal 3. So at 1, it's 3. At 3, it's 3. At 4, it's 3. At 5, it's 3. At 6, it's 3, so on and so forth. The blue says x is always 2. I don't really care about my y, so that's why it's vertical in there. Okay? So that's kind of a review on linear functions and their graphs.